He did use this structure.
All right. I guess today we may need graphing calculators. So if you don't have one, go ahead and grab one real quick here.
Idiot.
Alright, today we are going to take a look at solving higher degree polynomials. Okay, solving higher degree polynomials. We looked at that a little bit in the last section. We talked about solving cubics by using synthetic division. Okay? If we were given 1, 0, use synthetic division, get down to a quadratic, and then solve that quadratic. Okay? Today we're going to do something similar, but just take it one step further. So the first thing that we have to take a look at is finding all of the possible rational zeros of a polynomial. Okay? Now we could have irrational zeros, we could have imaginary zeros, but this method will let us find all of the possible rational zeros of a polynomial. Okay? To do that, what we do is take all of the factors of the constant term over all of the factors of the leading coefficient. So what that looks like, okay, if we have this polynomial down here, my constant term is 3. Right? We don't worry about the signs because we're eventually going to take positive and negative of everything. So we don't worry that a negative 3. So what are all of the factors of 3? 1 and 3, right? So when I'm listing these possible rational zeros, I'm just going to start by listing all of the factors of the constant term, my numerator. Then, in the denominator, we're saying that Q is all of the factors of the leading coefficient. So what's my leading coefficient here? 2. So what are all the factors of 2?
1 and 2.
And I'm eventually going to take all the positive and negative values of these. So what this looks like, what this actually means, I'm going to start with the 1. Okay? I'm going to say, well, I want plus or minus 1 over 1. Then I'm going to say I want plus or minus 1 over 2. I'm just taking this for the same thing with the next factor in my numerator. So I'm going to take plus or minus 3 over 1. And then plus or minus 3 over 2. Okay, so it's just all of the factors of the constant term over all of the factors of the leading coefficient. So we've come up with 8 different numbers here, right? Positive 1, negative 1, positive a half, negative a half, positive 3, negative 3, positive 3 halves, negative 3 halves. Those are the only places where this polynomial could cross the x-axis, okay, in terms of rational zeros. Okay? We could have irrational zeros, but in terms of rational zeros, these are the only places that we could cross the x-axis. Okay? So this narrows down our search for possible rational zeros quite a bit. Right? We only have 8 possibilities. To actually, we're going to use our graphing calculator to help us. So go ahead and in your y equals, go ahead and type in this polynomial here.
Yes?
Type that polynomial into y equals and calculate.
Mr. Fast.
Sounds like you're.
So, all those constants. I'm confused. Yeah, he does. You just get a big straw. And you write it right now.
Which you said. All right, so once we have this graphed, what we're going to do is look for one of these places, okay, where it crosses the x-axis. We just want to find one of them. Okay, it could cross it more than one of these, but we just want to identify one of these places where our graph, where our graph crosses the x-axis. So what do we see? Can we find one of these zeros on the graph? Which one? -3? Is everybody at -3? Okay. So once we find that value, what we're going to do is add that zero or that factor out of my polynomial. So I'm going to set up a synthetic division problem. Okay, we found that that zero is -3. So now I'm going to write out my coefficients of my polynomial. So 2, 5, -4, and -3. Now we just synthetically divide. So bring the 2 straight down, multiply, -3 times 2, add, multiply, add, multiply, add, we get 0. And we should get 0 as the remainder, right? If we're identifying this as one of our zeros, my remainder should be 0. So what does this mean? What have I figured out here? What is this? It's depressed. You're right. This is our depressed polynomial, to use correct vocabulary. So what is that polynomial then? Is it 2 minus 1 minus 1? There we go. Right? So since I started with a cubic and I divided out a linear factor, that means this will be the coefficient of a squared term. So this will be 2x squared minus x minus 1. Now we just have a quadratic. Okay, how can I solve this quadratic? Yeah, we can try to factor. Now, not all of the, once we get it down to a quadratic, not all of them will factor. Okay, but that's the quickest way to solve a quadratic, so it's worth checking to see if it will factor. What's that? So yeah, the foolproof way, the way that would work every time, would be the quadratic formula. Okay? And that'll work even if we could have factored this. Okay, but it is usually worth checking to see if it factors, because that's a little quicker than using the quadratic formula. But if you just want to use the quadratic formula every time, that's fine. Alright? So, what is the quadratic formula? Just so that we have that down here. Do we have it memorized?
B plus or minus the square root of b squared.
It starts with B,
I'm disappointed that you didn't sing.
yes, people are vaccinated.
Okay, so quadratic formulas, okay, we should have that memorized. We do need to have that memorized here. Okay, if you don't have it memorized, make sure you get it memorized. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so how do we want to solve this one? Do we want to try to factor it or just use the quadratic formula?
Let's just use that formula.
Just use the formula? All right. So x equals the opposite of b. So b is -1. So that'll be -1. So 1 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we get 1 plus or minus the square root of 1 plus 8 9 over 4. So 1 plus or minus 3 over 4. So we can then do both of those, right? 1 minus 3 over 4 would be negative 2 over 4, which would be negative 1/2. And also 1 plus 3 over 4, which would be 4 over 4, which would be 1. Okay, so we could have done that by factoring, okay, but quadratic formula will work every time. Okay, so it's whatever you feel more comfortable with. Okay, if you want to try to factor, you can try to factor. If you don't want to mess with factoring, you can just do the quadratic formula every single time. Okay, so we want to make sure that we list our 3 answers. Okay, at the end, what are my 3 answers? What are my 3 zeros to this polynomial? Negative 3, negative 1/2, and 1. Those are my 3 solutions. Okay, any questions on this process? Okay, so we're going to find all the rational zeros by listing out all the factors of the constant over all the factors of the leading coefficient. Use our graphing calculator to identify one of those, synthetically divide it out. Okay, now we may have to use synthetic division more than once, right? If we had a 4th degree polynomial, for example, we would have to use synthetic division twice to get down to a quadratic. Okay, so we would have to choose a 0 that we see on the graph, and then choose a different 0 once we get to our depressed polynomial. Okay? Right, yeah. Then you have to do it 6 times. Yeah. Any other questions on this so far? So, in this section, we're just looking at real zeros. So, I mean, it is possible that we wouldn't have any rational zeros, or that we would just have imaginary zeros. For what we're doing today, yes, we will be able to find all of the zeros using this method.
Are they going to be? That again, I forget what the formula is called. Is it going to be a nice square?
Not always. I mean, we could end up with irrational zeros once we get to this point. I mean, we could have like 2 plus or minus the square root of 7 over 4 or something like that.
But it wouldn't be like plus or minus 2 root of 3 or something.
It could be. Yeah, it could be.
Mr. Fetch.
All right, so you guys try the next example here. Okay, so list out all of the possible rational zeros first by taking all of the factors of the constant over all the factors of the leading coefficient. Then use your graphing calculator to identify one of those rational zeros, synthetically divide it out, and then solve the resulting quadratic.
Wow. That sounds very simple.
It does. 1/2, 2. Let's see.
I did too.
Mr. Fetch, do you have any questions?
Sorry.
How do I even know? one thing I know. It's that teachers are worthless if they don't have crack. I'm trying to tell you, Mr. Patchley, I don't really do you like that, but it do. It do be.
Like that sometimes.
Kind of makes me think about Joe, you know? Yeah, Joe. Do you know Joe? Swerve. That is the answer.
Yeah.
Pretty sure that's not how that works. I'm pretty sure that's not how that works. Yeah, you're still gonna get it.
Holy shoot, that was fast.
What about you?
Alright, did we get -2 and then 1 plus or minus the square root of 33 over 4? Alright. So on this one, we couldn't have factored our compressed quadratic, right? We had to use quadratic formula here to solve. Questions? Okay, so we do have a note down here, right? Irrational zeros always come in conjugate pairs. So here, right, this was an irrational zero. It's actually 2 different irrational zeros, right? 1 plus the square root of 33 over 4, 1 minus the square root of 33 over 4. So what that means is, if the square root of 7 is a 0, then its conjugate, negative square root of 7, would also have to be a 0. If 3 minus the square root of 2 is a 0, what's the conjugate of 3 minus the square root of 2? 3 plus the square root of 2, right? A conjugate just means all we're doing is changing the sign. Okay, so that's what we're doing here, right? 1 plus the square root of 33 over 4, and 1 minus the square root of 33 over 4. Right? Questions so far? All right, let's try another one. Okay, so why don't you guys go ahead and try example 3 here. See what you come up with. So start by listing the possible rational zeros.
Mr. Fetch, I didn't catch what you said for this.
So a conjugate pair just means we're changing the sign, right? So if the square root of 7 is a 0, then negative square root of 7 is a 0. And 3 minus the square root of 2 is a 0. 3 plus the square root of 2.
Mr. Fetch.
1, 2. Oh, I did what you did. We put 2 over 2, and 1 over 1. What do you change? What is, I don't understand that change. So, what is that one?
Seven students, please excuse the interruption. Any psychology students that are going on the field trip with Mr. Brooklyn, please report to door 22 by 9:05. Thank you.
That's. Alright, Mr. Fetch, I'm skipping the class.
Alright.
Because I hate being here. It's stupid. Go, like, sell me some crack later. God, you are so not useful.
No crack.
That's not even fun. That you don't.
Fractional math is the not fun.
Fractional math is the not fun one. Alright. Guessing some of you don't know how to do what I did real quick, so I'm going to show you on the calculator here. How to quickly find that 0.
Yeah. Dude, I want to put one on my phone.
Come on.
It won't let me graph, but love you today message mentions. Like, it won't
Just
let me
going
look
on
at
the road, you just hear a scooter with just a turtle whistle. Hey, you know there's a whistle.
Oh.
Did you get two scooters? That's exactly how it sounds.
It just had one of the
Oh, that's a supercharged.
lots turned on.
I don't really know what that means, but I
It slowly
Yeah.
exhales.
Okay. There we go. Alright, so Alright, so I was able to quickly figure out okay? The easiest way to find a zero of a polynomial using the graph is to use the zero feature. Once you have your polynomial graphed, what we can do is go up to calc, okay? It's second trace. So if you hit second trace, it gives you a bunch of options. You can find a specific value, you can find a zero, you can find a minimum, you can find a maximum, you can find where two functions intersect. We're going to use the zero feature. Okay, so either scroll down or press 2, and it's going to ask you a few questions. Okay, so if I first want to test and see what this zero is, it's asking me to choose a point to the left. So I'm going to move my cursor, so I'm just going to get my arrows going here and choose, so I can see my dot coming up here. I'm going to pick a point to the left of that zero. Okay, so I'm to the left now, so I can hit enter. It's going to ask me to choose a point to the right. So I'm going to move my cursor up here, so I'm to the right of that zero. Hit enter. Then it asks you to guess. So I mean, you don't really have to guess, but if you want, you can move your cursor close to the zero. And then it tells me that zero is at negative 2.6, negative 1.5. So that's how I quickly found that that's the zero I want to use. That is on my list of possible rational zeros, right? So then I use that to do my synthetic division, come up with my depressed polynomial, and solve. Alright. We okay with that one? Questions on that one? Alright, let's do one more then here. This one we have a fourth degree for the last example on here. Okay, so first step is to find possible rational zeros. So take all the factors of the constant over all the factors of the leading coefficient.
have to do it twice. That's what it sounded like.
Yeah. Oh, zero. I didn't see that. What's 3 times? Did you get it to the cube one? The cube oh yeah. You should do it again. What was the second zero? I did it once. I'm trying to find the actual. No, it is. I don't find it.
Well, yeah. You don't have to see it on the screen.
Maybe
Yeah. Live square plus 6.
Where'd you guys get a slide?
Yeah, so that one's not rational. There is another one that is.
Oh, we had to solve it.
All right, let's go through this one together quick here. So we get a long list of possible rational zeros, right, by listing all the factors of 12 over all the factors of 3. Then when we graph this polynomial, we should find 2 rational zeros that we can see. Okay, using that zero feature, we can find 2/3 is a 0. I mean, it will come up as 0.666666666 on your calculator, but we should know that that's 2/3, right? And then 3 is also a rational 0. So it doesn't matter which one you use first. Okay, I chose 2/3 first, but you could use your 3 first and do synthetic division. Remember to include placeholders if we're missing any values, right? We don't have an x squared term here, so I had to throw a 0 in there. Once I divide that out, I end up with a cubic. Okay, so I would have to do this process again. So I'm going to use my other 0, we found to be 3, on this depressed cubic now. Once I do synthetic division, I end up with a quadratic that I can solve. When I solve that, we get plus or minus the square root of 2. So my 4 answers here are 2/3, 3, positive square root of 2, and negative square root of 2. Okay? Any questions? Logan.
Would it matter what order you do the zeros in? Because I did 3 first, and then I did 2/3, and I got real funky numbers.
It should not matter. You should get the same answers either way. So yeah, you could definitely do 3 first and then 2/3. We should get the same thing. Did you remember your 0?
Yeah, I had the 0.
All right.